Hi, welcome back to our Flipped Algebra 2 classroom. Tonight we're going to take a look at 5/6, the quadratic formula, and then discriminant. Key vocabulary, quadratic formula, and discriminant. So what is the quadratic formula and what's it used for? Well, we've been working with quadratics here, which are these equations, the ax squared plus bx plus c, and we've solved them through factoring and graphing and things like that, but we're always looking for an easier method. Factoring's not bad, but not everything can be factored. Graphing is very time-consuming, so we want the quick way. How can I do this relatively easy? And that's where this quadratic formula comes in. Quadratic formula is this formula right here. It's the equation negative b plus or minus the square root of b squared minus 4ac all over 2a. A couple things about this. First off, it has to be quadratic in order to use this formula. It's not going to work for cubes and fourth roots and things like that. It has to be square, it has to be quadratic. The a is the number in front of x squared, the b is the number in front of x, the c is the constant term. And notice it has to be equal to 0 in order for this formula to work. If it's not equal to 0, that's your first step. Simply plug everything in, go through. The plus or minus is here because you will get two answers. Just like we've been solving before, the graph parabola can cross the x-axis in two spots, so you could have two possible answers. Also, the thing that's underneath, the b squared minus 4ac, that's what we call the discriminant. And that discriminant actually tells us about our solutions before we get there. So let's take a look at that discriminant. So here's my discriminant. The b squared minus 4ac is the part that lives underneath the radical sign. If that discriminant's a positive number, and that positive number is a perfect square, so if it's 1, 4, 16, 25, that means you're going to get out two real rational roots. Rational means it can be written as a fraction, so your answer might be a half, might be 2/3, but it's a fraction. If that discriminant's positive, but it's not a perfect square, now you're going to end up with something like square root of 3 in your answer, square root of 5 in your answer. That is not in a rational number because that square root can't be written as a fraction. So you're still going to end up with two numbers, two real numbers, but those two numbers are going to be irrational roots. Next scenario that can happen is if the b squared minus 4ac, the discriminant, is actually equal to 0. If it's equal to 0, that means we have one real root. That one real root is going to sit right on the vertex, and that means that vertex is actually going to be touching the x-axis. Third scenario is when b squared minus 4ac is negative, and if you have a negative underneath that square root, that means we have an imaginary number, which means you're going to end up with two complex roots. Graphically speaking, if you have two complex roots, that means your parabola will not ever cross the x-axis. Alright, so let's dive right in. Let's solve x squared minus 8x equals 33 by using the quadratic formula. So, the first thing we're going to do here is we're going to go through and we're going to put everything on one side. So we're going to say x squared minus 8x minus 33 equals 0. And once I have this equal to 0, I can now see what my a, what my b, and what my c are. And it's just simply a matter of taking that formula and plug it in. So we'll go opposite of b, which will be a positive 8, plus or minus the square root of b squared. Negative 8 squared is going to be 64, minus 4 times a times c. And that's all over 2 times a being 1. So all over 2. First thing I'm going to do is I'm going to go through and I'm going to compute the value of my discriminant, so the number that is underneath the square root. Now when I do this, make sure you follow your order of operations, meaning all of this is going to have to be multiplied first. So 4 times 1 times negative 33 is giving me a value of negative 132. So we're going to have 64 minus a negative 132 is now going to change that into plus 132. Once I do that multiplication, get that simplified, I can now add those two numbers together, which is going to give me 196 underneath that radical sign. And this happens to be a positive number, so I know I'm going to get out two answers. But what's more impressive is 196 actually is a perfect square. And that perfect square is 14. Last step would be to write out my final answers. So I have two answers here, remember. One which is 8 plus 14, or 22 over 2, which is 11. And I have x equal to 8 minus 14, which will be a negative 6 over 2, which is negative 3. So 11 and negative 3, my two solutions to the quadratic formula. Alright, let's try another one here. X squared minus 34x plus 289. So bigger numbers now. A is 1, B is negative 34, C is 289. It's equal to 0, so we're going to jump right in. So we go opposite of B, plus or minus the square root of B squared, which, if we put that in our calculator, looks like 1156. So B squared minus 4 times A times C. And that's all over 2 times A, so 2 times 1 gives me 2. So we have 34 plus or minus 2 on the bottom, square root here. I'm going to do all this in one step, so we're going to take 1,156 minus 4 times 1 times 289, which is going to give me a value of 0. Now, I like 0 because if you end up with 0, the square root of 0 is 0, which makes this just simply 34 over 2. Notice because I'm adding 0 and then I'm subtracting 0, it doesn't change the value of 34. And that's how we're able to get out one solution. 17. Alright, x squared minus 6x plus 2 equals 0. A, B, C already simplified, so we'll plug them in. Opposite of B, plus or minus square root B squared minus 4AC all over 2 times A. Gives me a value of 6 plus or minus square root. Complete the stuff on the inside, so we'll go 36 minus 8, which will be 28. 28 is a positive number, so I am going to have two answers, but it's not a perfect square, which means those two answers are going to be irrational. What I can do is I can go through and I can simplify square root of 28. 28 is 7 times 4. Square root of 4 is 2. So I have 2 root 7 over 2. And when I look at this final answer, I want to try to simplify as much as possible. And I can pull out a 2 out of everything. Now, when I look to cancel stuff out, I'm not looking to cancel out underneath the radical, just the stuff on the inside. So if we divide everything by 2, we end up with 3 plus or minus 1 root 7 over 1. And there's my two answers. 3 plus root 7, 3 minus root 7. Alright, x squared plus 13 equals 6x. And here's a common mistake. Everyone looks at this, they see A, they see B, they see C, they start plugging stuff in. But they forget to get everything on one side. So let's take care of that first. Put everything on one side, and now I can follow what I have. Opposite of B, plus or minus square root of B squared minus 4 times A times C all over 2 times A. So we have 6 plus or minus 2 on the bottom. We'll figure out what my discriminant is by taking 36 minus 4 times 13, which gives me a negative 16. Negative discriminant is telling me I'm going to have two answers. Those two answers are now going to be complex numbers, meaning that they should have an imaginary numbers, which makes sense because square root of negative. Square root of negative is going to give you the I. So if we do a little bit of simplifying here, we get 6 plus or minus square root of 16, which is 4, square root of negative 1, which is I, all over 2. And again, much like the last one, I want to try to simplify 6, 4, 2. They're all divisible by 2. So that will simplify to 3 plus or minus 2i. Quadratic formula, great tool. This is a formula that needs to be memorized. It's a formula used very often. We're going to start to apply some of these problems. It's something you got to know quickly, and you got to know how to use it and understand how to use it. So give the self-check a try tonight, and we'll see you tomorrow in class. Have a good night.